Right, welcome everyone to Amplifying F# Essential Lectures. Today we will continue where we left it the last week. So today we will be covering a deep dive into collections. So yeah, without further ado, I will give it to Ian so we can start the session. So I will, stop sharing. Ian, it's yours now. Lovely, I can see it.
Okay, right, so my screen's up and running. So welcome to session 4. So this is the last of the fundamentals of the essentials, if you like. So this is the last of the building blocks, and we'll be getting on to some more useful stuff where we combine all these things together over the remaining 8 sessions. So this session's about collections, but I'll do a quick recap on the last session, because it's some of the stuff that we did is going to come across today as well. Certainly the option is going to come across. We're going to be using that today. And then we'll spend the rest of the session looking at F# collections. So I go to my recap. So the last session we covered effects. So I covered options and result last time. So option is a simple discriminated union where the data is either sum of a particular data type or none. So we use it for one of the things we use it for is instead of null. So we don't really use nulls at all in F#. Instead, we use the option type. So as I said, it can either be none or it could be sum of something. And then to extract the value, because it's a discriminated union, we use a match expression. So that's from line 10 here. So if we match it, it's either sum of a value and we can extract the value from that, or it's none, so it has no value. We also looked at the option module. We'll cover more about modules next week. But basically the option module is just a container with a lot of nice little helper functions. So obviously the .NET framework and C# code, there's a lot of null stuff comes out of it, some deliberate, some not. And because we don't use nulls in F#, we use the option type. We've got 4 little helper functions in there. So there are 2 which convert from the .NET type, so reference types and nullable types, into an option, and from an option back into a reference type or a nullable type. And again, that will do the null conversions automatically for you to none and back again. And then we spent some time looking at function composition. So in session 2, we looked at function composition where everything lined up, where the output from the previous function matched the input to the next function. That was really simple. We looked at the forward pipe, etc. And then in session 3, we looked at because you've got effects on the output, so because you're returning an option or a result, the next function you don't write the next function to handle that, to receive an option or a result. You just write your functions to stand alone. And then we looked at how we actually compose functions together that are designed like that. And we looked at how we expand all that out. We come up with map and bind. So with the option dot map and option dot bind, what we've got, the only difference between the two is that the function that we're using in the map case is a simple a to b. So it could be an int to string, it could be an int to int, it doesn't matter. But it's not wrapped in the effect. Whereas with bind it is. So the function that we had the divide function, or try divide function, that returns an option of int. And then the multiply function that we did with map just returns an int. So that was the difference between the two. And then we looked at the result type, which returns OK of success or error of type failure. And again, we've got exactly the same thing. So result.map takes a function that takes one type and returns another type, which could be the same. And the bind version returns a result of the second type or an error or something or another type. We'll get on to we'll do a lot more result stuff next week and the week after as well. So we'll really dive into that. So that was what we covered. That was what we covered last week. So what we're going to cover this week is collections. So there are two sides to collections in F#. Because it's .NET, you can use any of the .NET collections. They're sometimes useful, sometimes not, but I recommend that you look at the F# versions first, and only if you can't find something that suits you, look at the C# version. So we do sometimes use the C# list, for instance. That has some interesting properties that are quite useful, mutability being one thing. But we're not going to cover that in this particular session. So F# has, or certainly I'm going to look at 5 different collections today. So I'm going to look at the F# list, which is a read-only immutable list. And we're also going to look at an array. So array is very similar to arrays in the rest of .NET. We're going to look at the sequence, which is the F# version of, or an F# name for IEnumerable of T. We're also going to look at map, which is a dictionary, and then we'll look at the set type, which is something that doesn't exist in C#, which is quite a nice little thing to go with. So we'll start off with the list. So I've got some little notes here for things that I'm going to cover as we go through. So we'll start off with a simple comprehension. So we're going to create a list to begin with. So create my list. So the simplest way to create a list in F# is to just do something like this. So if we wanted a list of 1 to 10, we can do that. If I highlight it and run it with Alt and Enter inside the F# interactive window, I get a list, as you can see there, ordered 1 to 10. There's lots of nice little bits in there, like I could do so I can start at 1 and then add 3 and get the numbers up to 10. We'll run that. You can also go backwards, so it's quite useful. There's but that's actually just a shortcut for in. So we do have for loops as well inside of this. That's just a shortcut for that. It's exactly the same thing. So the list is immutable, which means it obviously can't change. So I can't add an item as such to a list. What I actually do is I'm not creating a new list. What I'm doing is pointing at the old list and adding things to it. So if I want to add an item to data, so if I want to add 1, I can use the cons operator, which is : : And if you look, I've now got, if you look at my list, actually, if I change that to a 7, make it more obvious. You'll notice that 7 gets added to the start of the list. So it's not added at the end, it's added at the start. And data remains the same. So I can run. So as I said, it's an immutable list. All it's doing is new data is a 7 and it's pointing at the original list of items. So one of the nice things that we can do with the list is we can actually, I've got another one. I've forgotten my my creation. Oh, I haven't. I've got it later on. Okay, so I can create a list. What I can also do is I can pattern match on that list. So if I take my, so I'm going to write a little little pattern match. Oops. Let's do. So I'm going to write it as a function. It might be easier to do that. I'll write a function called get list. Pass the items in. So there are 3 things that I can test for with a list. So I can test for an empty list. That's just open square brackets, close square brackets. I'll just return a string from this. I can test for a single item, and the name in their item is just a name. I could call it whatever I wanted. It just allows me to extract the value. So this is a list with a single item inside it. So and the last one that we've got is I can use the cons operator again, and what we actually have is a head and a tail. So a head is the first item, and the tail is everything else. Again, they're just names. They're not. They don't have any meaning. But I'm going to call them head and tail. So let's try some things out. So get list. If I add that into there, the get list returns an empty list. Get list with an item with 1 returns that. And something with a bit more returns a head and the tail. So as you can see, the head is the first item, and the tail is everything else. Okay, I can also, if I comment out the single item and run that again, and if I go back to my single list, what we find is this still works because you've got a head and it gives you an empty list for the rest of it. So you don't have to test for the single item. So actual head and tail is just fine in this situation. So pattern matching works with a list. And that's a really nice thing to do. Once we go on to things like recursion, we'll use this quite a lot. So the module versus dot. Let's take my so I've got data up here. Make sure that's what it is. Right, so in C#, we do things like this. You dot into the instance, and you'd have some methods and some properties available. We still have some of those in F#. There's nothing wrong with using them. There are a number of people that say don't, but it's not really a problem. But obviously, it's not designed to fit in with things like using the forward pipe for composition. So they do make sense sometimes. So if we take data.head, if I run that, this head is 1, data is indeed 1, 4, 7, 10. Okay, so the other way to do that is to do the forward pipe, to use the list module. And again, I get the same thing. If I now just do list and dot, you'll see there's a lot more functions available. There are, I can't remember, there are probably 50 or 60 different functions available that do all sorts of really nice things. And we'll go on to some of those later on. Right. Init. So we can initiate a new list by doing, so I'm going to create a little helper. Using system.random. And I'm going to do I'm going to do list dot init. And you can see you get lots of help with this sort of thing. You move the mouse over it. So it's telling you it needs a length and it needs an initializer. So the length is an int, and the initializer is an int to type of t. So the int on the initializer is actually the index. So I say I want 10 items, and I need to create a little function. So I'm going to create an anonymous function. So I have access to the index, and let's create this with let's create a little tuple. That's going to be a random number between 0 and 100. So a very quick way of creating a list with some numbers. So filter. Filter is just like where in LINQ. So you take a list, and we're going to filter it. So let's create a list. And let's get the even numbers. Okay, 2, 4, 6, 8, 10. Nice and easy. So map. We obviously met map last week, and I'll go back on to, I'll cover a little bit more about map later on. But map in a list sense is like select in LINQ. So if I take my list again, so what it does is for each item, it performs an operation. So it converts. So we have a function that takes one data type and converts it to another data type. And we pass in a list of the first type, and we get a list of the second type coming out. So I've got a list of integers going in, and I'm going to convert them to, I'm going to double them. So I'll get a list where every single item is doubled. So reduce and fold. So everything we've done so far, so filter takes a list and filters it down to a subset. Map takes a list and converts each item to an individual item. So reduce and fold are aggregate functions. So they're to take a list and return a single value. So if we wanted to do something like add up the numbers, so do a sum. I can use list.reduce. So list.reduce has two parameters. The function that's required in there has two parameters. So the first one is an accumulator, and the second one is each item. And all we're going to do is just add them together. So what this does is loops through. It takes the first item as the initial value, and then adds the item to the accumulator each time, and you end up with the total. So hopefully we end up with 55. Which we do. So nice and easy. So reduce is quite a nice little function to use. There are simpler versions of this, so I can simplify that, but I'm not going to in this stage. I think it's more important that you understand how things like aggregation works and get used to using anonymous functions. I think that's more important at this stage. So there is another thing we can use that's very similar called fold. I can actually copy that. But there's one slight difference here, and that is that you have to supply the initial value for the accumulator. So if I run that, hopefully we get exactly the same thing. We do. Okay, so reduce does work a lot of the time, but folds are much more useful thing. So one of the problems with reduce is that if I do something like this, if I send an empty list into reduce, it actually throws an exception. So reduce is what they call a partial collection function. So there are some values of a list that it will not work for. So there are quite a few of those in the list module. Some of them have another version which starts with the word try. So if you had an empty list, for instance, and you tried to get the head of an empty list, that would return an exception. So there's a corresponding try head which returns an option. Sadly, there isn't a try reduce because it doesn't need to be, because fold will do the job for you. So having used aggregate in C#, fold is much simpler to understand than aggregate. Group by. Let's take our list. So I'm going to take a list. So another thing that we can do is we can join two lists together. So I'm going to use the catenation operator. So that's the @ sign. And we'll go 5 ... So if I join those two together, get a nice list of things. And I'm going to use the group by. So I'm just going to group by the value. This obviously looks a little silly. There is a shortcut for that called ID that you can use. So if I do the group by, what it does is it basically converts it into a tuple of key and a list of, so the key is the ID, is the item, and then it has a list of how many of them there are. So if I run that, so I don't know if you can see this at the bottom of the page. So what I've ended up with there is a list, because I can see the square brackets, and then I've got tuples. So there's only one of 2, 1, 2, 3, 4, but there are 2 lots of 5s, 2 lots of 6s, etc. So that's group by. It's quite a useful function. Let's comment that out for the moment. Iter. So there isn't a for each for such as such. There is a for each in F#, but there isn't a for each in the list module. Instead, there's an iter function. So if I do, oops. And what the iter function needs is an action, so it's something that takes a value of some kind and returns unit. So it doesn't do anything in effect. So the simplest one to do with that is print. I'm going to print as you can see, get the list of 1, 2, 3. Printfn is just an F# way of doing a console.writeLine in effect in this case. So we already, as I said, we already talked about partial versus complete and reduce. So if I just prove it with head. So list.head. Well, it doesn't like the fact that that I'm passing an empty list in directly in, explicitly passing in an empty list. We'll do that with try head, hopefully.
I think you can wrap that into parentheses, maybe the author scope, because it basically doesn't like that you are I think basically accessing that as a value. It needs exactly, yeah, exactly, yeah. It's a value restriction.
It's not a list, is it?
No, the last one needs to be an option, yeah.
Okay. Okay, the initial list was empty. Thanks, Edgar. Okay, and that one comes out as none. So as I said, so there are 10, I think, or close to that, try functions, and they're all functions that are there because the version without the try could fail, because particularly for empty lists. So they're things like indexes and head and that sort of thing. Okay, so let's try a little bit of composition. So we're going to try and return the sum of squares of the odd numbers between 1 and 10. So first one I'm going to do is filter map and sum. So if we take and do list.filter. So I want the sum of the squares of the odd numbers. So I need to filter out the I need to filter it so I only return the odd numbers. So that's that. So if I just put nums in there, it's got 1 to 10. Let's just try that out. So that, yep, that's return 1357. Okay. So the next stage would be to do the map. And I want some of the squares. So I need to do x star x. Let's try that. So yeah, that's squared everything. And then I need to sum it. Okay, run all of that. 165. Okay. So it's such a common thing to do things like filter and map in this way, and there's actually a slightly simpler way of doing this using the choose operator. And what the choose operator does is uses the option type to let us do this. So list.choose. So we need to create a chooser. So this takes the t, in this case it's an int, and return an option of int. So to return the option, I need to say, well, if the number's odd, so if then I return sum of the square, also return none. And what choose does is it only returns the values that are sum. So it unwraps the option for us. So anything that's none, it throws away, and anything that's sum, it just returns the values. So you can see it returns an int list, not an option list. So I can do that. It looks fairly similar to what we had before. And then I do list.sum 165. So that's the same value. Right, reduce. So remember, reduce has an accumulator and an item. So I can copy that, although I can't use the options. Let's change that to item, that to item, that to item. And I need to add that to the accumulator. So that's saying I take the accumulator, and then if the item's odd, then I add the item times item to it, or else I add 0. Okay, in this particular case, that does work. You have to be very careful with reduce though, because depending on how you work with this is actually pure luck that this worked, because I started with a 1, and 1 squared is still 1. So if I reverse this list, so it now goes 10 to 1. And do that, you'll see that I don't get the same value. So be careful with reduce. Because it doesn't have an initial value, if you run calculations on the values that you pass in, the first item does not have that calculation applied to it. So you have to be very careful with this. So what we can do instead is use fold. Oops. And if you remember, the only difference with fold is that we supply an initial value. And that returns the correct value. And if I do a reverse, I still get the same value. So that's still correct. So fold's a much safer thing to do with this sort of thing. And obviously, it's such a common thing to do. Things like this that there are built-in functions for sum already. So we've already seen sum on its own. So sum will just sum up an individual set of values. In this case, we need to use sum by because we're going to run a calculation. Okay, so this takes a projection. So it's a bit like a map. So I'm going to take that one. Run. I don't want that one, do I? Oh, that should be correct. What have I done wrong here?
Maybe you had something on the interactive session before that had modified the nums, so you will need to maybe find the initial nums or the one that you.
I know what I'm doing. Yes, sorry, I haven't done the I haven't done that side, have I? I've only done part of it. If I do, that one's going to be a better one to take. Oops. That's better. Yes, I forgot that I was. It's the sum of the squares of the odds, and not the sum of the squares of everything. Whew, get there in the end. All right, another nice little one to do. FizzBuzz. Everybody loves FizzBuzz. I certainly do. So let's have a go at doing it by using a list. So I'm going to do a list of tuples. So FizzBuzz, as everybody knows, if a number is divisible by 3, you put fizz, and if it's divisible by 5, you do buzz. It's a function. I'm going to do a map. So I'm going to go through each item of the list. So I'm going to deconstruct the tuple. Call it value and message. I'm going to say if input is divisible by value, then message, else it's an empty string. Why doesn't it like that? I need a test. It's divisible. I've got to test it against the value, haven't I? Right. So let's do let's try this out. Okay, so that works for that. If I try 15, that seems to be okay. Let's try. Okay, that looks like it's doing all right so far. So I've now got a list of, so when I run this, the list.map converts the tuples into strings. It's either fizz or empty string or buzz and empty string. And now I need to concatenate them together. So I'm going to use reduce. So an accumulator and an item. So I know I can use reduce. I know it's going to work because I'm in control of the input list. I know there are 2 items in the list. So I can just do put item. Let's try this again. Okay. So the last thing that I need to do is I need to say that if it's if the string that I get back is greater than an empty string, then that's okay. Otherwise, I need to return the string version of the input. So if all equal to empty strings, then I return the input as a string. Run that using interactive, and then I can try FizzBuzz. Let's try. Bracket. Okay, so for 1 to 20, let's run FizzBuzz on each one. That works nice and simple. So just the same as method grouping in C#, if you see this sort of pattern with X and just the thing at the end, we can actually just get rid of all of this apart from the FizzBuzz part. Oops. And that works as well. Exactly the same way. Other things that we can do with the list module is we can convert the list into other types as well. So we have list.toArray, and a list.toSequence as well. And we can also go the other way. So we can go array.ofList and sequence.ofList. So it's very easy to convert from one to the other. So I talked a little bit earlier about map and bind. So we saw list.map in this. So looking at option.map, what list.map should look like is something like that. And actually it is. So let's have a look at what list.bind would look like. Okay, you'll notice that bind doesn't exist. There is a reason for that, and that's that bind is used for something very specific. And I'm not going to mention the M word, but yes, they're for monads. We've actually been doing monads already in this, even though I haven't mentioned the word until now, but it doesn't really make sense with a list to do that. But what there is there's a function called collect. And collect has that signature. So you can still do it. So if I take this one, for example. So if I take a simple list of 1 to 4 and I use collect, and I have a little function that creates a new list that goes from 1 to whatever each value is, I'll end up with a list that contains, so it creates a set of lists and then undoes all the lists just to create a single list as a single item, as a single result. So I get 1 to 1, 1 to 2, 1 to 3, and 1 to 4 all joined together. So it does exist. So we've got similar patterns all the way through. So although list has similar things that work, it's not really an effect as such. It's just, I mean, it's not pure luck, but it's yeah. Right, so that's list. So we've covered quite a lot in there. Basically all the stuff you can do in things like link, you can do in F#, but also we get things like being able to use the forward pipe operator and being able to test individual parts of the composition rather than having to run all of it.
One of the favorite things that I love to do is go, when I'm, trying to work with data that's coming from a, source like a database or an API, is to explore what is available in F# core in the list, because, as you said, there's different ways of doing things, and yeah, I also, use a lot the list.concat or array.concat, where you kind of I guess maybe reduce, or you can go from a list of a list to have an actual only list, so you can use so yeah. And the collect thing, I haven't used that yet, so yeah, so I was really surprised about that one. Fold as well is something that I didn't understand until today, so thank you for that. It was one of those, it was like, yeah, folds seems like complicated, but it's actually not. So yeah.
No, they're not. No,
Yeah.
so as long as you understand the basics, as long as you understand that it takes that you end up with that you've got a curried function that has an accumulation and an item, and then it's just how you work with those. So
Yeah.
so yeah, it's much simpler than aggregate is in C#.
And the good thing is, like, in .NET, there are, the latest versions on there's a lot of optimized collections on LINQ. So in the latest release, maybe 8 and 9, they have been added a lot. And I think maybe when you were typing, there was I saw also the LINQ namespace available. So that's really good in F#. If, for example, you're doing some high performing code and you want to use those vectorized collections that are more performant, you can still do that in F#. You can, you can get access to LINQ and use all of those. At some point, F#, I'm sure will also, improve the collections or the performance of the F# collections. But yeah, it's really good that we can use the
Yep.
F# ones and then the .NET one as well.
Okay, did we get any questions from?
Yeah, we have one that says, I think is for the collect, is like select many.
Yep. Correct.
And an observation as well, something like doesn't recommend using FOL and instead using derivatives like sum, max, mean, reduce.
Yeah, try and use the ones that are specific. So things like sum by, max by, they're simpler to use than because they're single lines rather than having to do things like map and filter.
Mm-hmm.
But sometimes you have to do map and filter.
Yeah, definitely. And the trick as well, like if you are doing filter and map, you might as well use choose as well, like
Yeah.
rule of thumb. And we have another one, is reduce impure then?
It's a higher order function, so technically they're all impure, but no, it's a partial function. So it means that there are input values that you can pass into it for which it doesn't work. So an empty list in this particular case is one that it doesn't work for. I've only shown integers here, but obviously any type can be used. So if you use a record type, you can use the properties of records for things like sums. So all of this just works. It's one of those things where if you find yourself with the spare 15 minutes, once we look at loading data in, find yourself with the spare 15 minutes, load some data in, and just try and answer some questions on that data. So just run the functions against it.
Yep.
Yeah, and just practice it. It's good fun. As I said, there are 50 or 60 different functions per module for these collections, and they're really interesting how you can work with them.
Yeah,
Very quick to work with, and then you can get things like graphs and charts out as well.
yeah, definitely. I have seen some suggestions as well in the language to add more, more useful functions. So yeah, F# in the future will have they will extend those collections as well. Right, I think that's it. So Hubert asked that in Haskell we also have fold left, I guess, and fold right. I
Yeah,
don't think
there's fold back
fold back. Okay.
in F#. So fold works from the left to the right, and fold back works from right to left, and the same with reduce. There's a reduce goes from left to right, or from head all the way along, and reduce back goes from the last item to the first item.
Cool. Yeah, that's good to know.
Okay, arrays. Arrays are very similar, and except if I can get the right. So it's an open square bracket and a bar, and then a bar and a closed square bracket for an array. So basically, it's exactly the same as a list, but the bars in there instead. And you can see down here, we've got a list above, which has just the square brackets, and then the array has the square brackets and the bars. So that's the only difference between them from that perspective. So if I want to get the value of item index 0, I can do this for the list as well, exactly the same. I can do that. It's indexed from 0, so if I find item 3 or index 3 obviously is 4 because it goes 1, 2, 3, 4. Equality. So the equal sign isn't how you change values. That just tests equality. So that says is the value at data 0 index 0, 5? And the answer to that is no, it's not. So how do I mutate it? How do I change that to 5? Because arrays, just like arrays in the rest of .NET, are mutable. So they're fixed in size, but each individual item is mutable. Well, I have to use that little operator. So the backward arrow. So if I change that, and now go and have a look at data, you'll see that item 0 is now value 5. So it works exactly the same as it does in the rest of .NET. So creating an array. So if you want to have the same value, because it's mutable, it's in a list, it doesn't make sense because the list is immutable. It doesn't make sense to create a list with the same value for each item unless that's what you wanted. But in an array, it doesn't really matter so much. So in an array, I can have an array of 10 items and they can all be 0. So then I've got init again. So create my little random thing again. Note that when we create a type from the .NET framework or from C#, we don't use the new keyword. We use the new keyword where we use iDisposable, but not for normal types. So for array.init, 10 items, and again, it's exactly the same. I need a little initializer. So I've got the index and the value of the output. So I'm going to create an array of tuples again. So exactly the same as I did with the list. So it's just a quick way of creating an array. Pattern matching, right? This is slightly different. A simple function. Let's match the input. So we're still going to use a match expression. So again, we have an empty array. And all we can test apart from that is if an array has 1 item or 2 items or 3 items, we can test that, but we have to specify it. So we have to know how many items there are in the array when we do this type of thing. Okay, and the only other thing we can do is everything. And there's probably no point doing that, so we're better off just doing the wildcard for that, because we've already got access to the array here. Okay, so that's all I'm going to cover with arrays. If you're used to arrays in C# or other languages, they work pretty much like everything else does. As I said, so they're a fixed size. You have to define them, how big they are, and then the data is mutable. So the next thing I'll move on to is the map. So map is F# version of a dictionary. So again, I've done my little created a random number generator. I've created a new list of all of this, and to create a map, so I've got a tuple. So I've created my list of tuples. So I've got an index and this, so I can just convert it to a map by using the map keyword. I do that. I've now got a map. I've now got an array. So I can do so I can access the data like that. And just like every other dictionary out there, so if you pass in an index, or sorry, if you pass in a key that doesn't exist, it's going to throw an exception, and it does exactly the same here. So we get a key not found exception. So what we can do instead is we can pass, we can use the map module, and in there we have lots of things like contains key, but the one that we want is probably try find. So I need to pass in the data, and it returns none. So it returns an option type for me. So that's a safer way of doing it. But you can still use things like, said you've still got things like key exists, etc. So there are all sorts of possibilities. And even when we dot in, you'll see that there are lots of built-in functions without having to use the map module. So you have a keys collection. So it returns a sequence. So maps are quite interesting. But we also have, it's quite easy within separate names for the moment. So instead of map, I have some built-in keywords called dict, which returns an iDictionary rather than a map. And we also have read-only dict as well, which returns an iRead-only dictionary from the .NET framework. So they all operate slightly differently. They have slightly different functionality, so it depends what you want to do. The majority of the times that when I use something like a dictionary in F#, what I tend to want is an immutable dictionary, and all I want to be able to do is use it for key lookup and quickly get access to data. So map is fine for that. I wouldn't. I don't need to use either of the others, but it's useful to be able to convert them and be able to work with the others as well. So the last of the types that I want to cover within this is set type. So to create a set, I use the set keyword and then something that looks like a list initializer. So that creates a set. So a set is unique items. So if you have a collection with multiple values in it, so if I do if I do 1 to 10, then I concatenate. So I just do a list of 1 to 10, then concatenate 5 and 13. And I use the set.of list. What you'll see is that set, or you would see, is the set only contains the distinct list. They're not ordered, it's a bag of items. So although it appears ordered as on the screen, it isn't actually ordered. There is no order to this. So they just treat it as a set, just treat it as a bag of items. So if I create my set 2, so I've got set 1 is 1 to 10, set 2 is 7 to 15. I can do things like the intersect. So what's in both sets? 7, 8, 9, 10. I can then do the difference. So the difference between set 1 and set 2 is, so it's the elements of the second set removed from the first. So 1, 2, 3, 4, 5, 6 are not in set 2, but they are in set 1. And then obviously the opposite works, and they should return 11, 12, 13. Yep, which it does. And then we get things like proper subsets and subsets. You remember your mathematics from back in school, they're quite useful. So proper subsets are all the items exist and there are extra items in the original version of the set as well. And subset is just, is it a subset? So they're sets. They're quite useful for some things. They're great for things like advent of code and stuff like that. They're often some of the earlier problems are set based, so they're quite efficient for that. So the last thing I'm going to look at is something slightly more complicated. So we're going to have a look at loading some data in. So we have a CSV file. And what I'm going to do is I'm going to load that data in. If you look at the CSV file, it's very similar to the stuff that we did in session 1, which is the customer data with the registered and eligible, etc. Okay, as we go through the next couple of weeks, we'll do some more on this, but we'll make it much more usable. All I'm doing in this particular one is to just get the data in. So if we go into here, I've created a customer record which has all of the data that we need. I'm going to load that in, and then I've source directory is just a little helper thing inside of F# that allows you to tell the compiler where the data is, where the code is. So if I run that tells me where all my stuff is. So what I'm going to do is I'm going to load the data. So if I do file dot, I'm going to use read lines. And I'm going to pass in the path. And you can see there that it returns an IEnumerable, or a sequence in this case. So I'm going to have a look at that data. Now, because this is an IEnumerable or a sequence, it's not physical because I haven't actually called it. All it is just saying it's a promise to say you've got some data if you want to. So we actually need to materialize it. So we can see there that we've got some data. It's a sequence because that's the IEnumerable thing for F#. We also don't see all of the data. We only see a subset of the data, although there isn't that much anyway. So it loads in so we've got a header row that we need to deal with, and then we've got 6 columns of data. So I've got my data, and we're in sequence. So I'm going to use the seq module. And I'm going to skip one row. So now I've only got the data. And now I need to pattern match for each line. So I need to do a map. So at the moment I've got an array. Sorry, I've got a sequence of strings. And what I need to do is for each line, I need to split that line up using the bar operator. So I need to use map. And I can use the split. The line's a string, so I can use split automatically. And I'm going to use the bar. Let's have a look at what that does. So I've now got a sequence of each line's now an array. So it looks quite odd. So it's a sequence of string arrays. So let's so what do I want to do from here? So I could do another map if I wanted to. So let's do that to begin with. Let's just do it let's do it the long way, if you like, and see where we get to. So now that I've got an array, I know that I can pattern match. But I need to know I need to know how many items there are. So I know there are 6 items. I also know what they're called, so customer ID, etc. So I'm going to copy the names from here. So all I'm doing is just creating some little types that I can use. Sorry, some little values that I can use to get at the data. So now that I've got that data, I can create a customer. Email equals email.
I think it's just the alignment that the
Yeah,
E.
it is. Yeah. Okay, so that's called eligible. And that's called registered. Right, that looks better. Yeah, it looks a little bit odd. I'm still getting the warning because it's an incomplete pattern match. So if so it's either going to be pattern matched to be a an array with 6 items in it that I can then set up to the customer, or I don't care what it is apart from that, and I'm going to raise an exception using fail with. So it's just going to throw an exception. So I'm just going to throw an exception if it fails for that. Let's try that. What do we get? I've now got some data in there. Obviously, I don't really want to do 2 maps straight after each other. I'd like to be able to combine them together, which makes a bit more sense. So the obvious thing to do here would be to take that line split, because all I'm doing in effect is passing that down, and put that into here. That means I can get rid of do that instead, and that now becomes line. Okay, still looks all right. Okay, but I want to run this as a function in effect. So I want to take the path and then pass it into there. So if I tidy this up a little bit, so I want the path. I pass that into file.readlines. What I'd probably do here is this instead. To make that a little bit more reusable. So let's load all that back in. And then run our function. And I've got all my data. So you can see that we can use collections, we can use types together. So in this, we've used IEnumerables, arrays. I could even complete the set and convert it to a list. And I could obviously tidy up this this map, so make it a little bit more readable, because obviously it's a bit extended. So I could export that into another function. But you can see here that we've combined together various things to make something quite usable. Okay, so that's where I want to stop at this point for today. Do we have any more questions from
Yes,
this?
we have a couple of them. So the first one is, would you normally throw an exception or use option when reading out the CSV file items?
It's entirely up to you. It depends on the situation. If you expect the data to be correct, I'd probably throw an exception. Or the other option is to return a result rather than an option, because the result would then allow you to put you could have every line that's okay would return a customer. So you'd return okay of customer, or you'd return error of string, which would be the line that failed.
Yeah, exactly.
So you'd be able to then look at you'd then be able to run something like a partition. So you'd be able to split the things that are okay and the things that are errors. And you just have a look at the errors and see what's wrong.
Yep. And another one is that in the same vein, would you use an option for the customer labels?
In this case, no, because they're all strings.
Yeah, exactly.
So an empty string is fine. We're going to move on. Once we're going to do validation in 2 or 3 weeks. 3 weeks, I think.
Yep.
So once we get onto that, we'll see there are a load of other things that you can do as well. So the idea of having So this has got strings all the way through. This normally wouldn't be called customer. This would be called something like potential customer or customer import. And then there'll be an actual customer with real types on it rather than this.
Yep.
So this is very much get me the data in. Once the data's in, I can then start validating it. So this is just parsing it. Then we validate it, and then we end up with a real customer.
Yeah, exactly. And in the F# community, there are projects like CSV provider, type providers that will, I'll also, generate some of these types for you, so you don't need to do it manually. But yeah, this is good to know really how you will do that in a, yourself rather than using some kind of magic for that.
Yes, I think it's important to understand how things work. So even if you don't end up using this in the end, so this particular thing about matching like this, unless you've got complete control over the data, this isn't a good way of doing it.
Yep.
So using something like CSV Helper
Exactly.
is a much better way to work. But this is just showing, how to do things like pattern matching with arrays, just in case you need to do it.
Yep. Perfect. So yeah, I don't think we have any more questions. So yeah, another great session, Ian. Thank you very much for that. I personally learned a couple of things with the collection, with all the collection functions, and yep, I'm definitely going to check my code and see if I can, maybe merge some of those into one.
Yeah, it's well worthwhile doing. But it's the great thing about this is that you can do it in stages. You don't have to get it perfectly right first time. It's get it working and then make it better.
Yep. Again, yep. Excellent session. Yeah, perfect. So let me take back the screen so I can quickly mention what we'll be covering next week, and then we can wrap up the session. So screen 2, share. So yeah, thank you everyone for getting through the session. It was as I say, an amazing session. We covered dive into collections, and next session we will talk about how you will organize your code, and we will talk about namespaces, modules, and yeah, all that
Yeah,
is really important.
there's a lot more stuff in there as well. There's a lot of general stuff in there. There's exceptions I'll cover testing.
Perfect.
We'll be creating console apps as well, and a
Yep.
test project. So yeah, there's a whole load of other things coming up next.
Yeah, you heard it first here. So yeah, please tune for the next session. And yeah, without that, thank you very much everyone for attending to today's session, and